Hi, this is Michael Goldfarb from SideFX Software. With the release of Houdini 18.5, SideFX introduced a new rigging and animation framework called KineFX that allows you to create and edit characters at the geometry level. Not only will KineFX allow for the editing of imported characters and the creation of new characters within its own toolset, since this work is being done within the geometry context, all of Houdini's stock surface operators can be used to edit and manipulate these character hierarchies. Since KineFX is new and many users may still be in the midst of production with an object-based rig, they may not be prepared to explore the new toolset fully. This tutorial will go over some of the basics necessary to import an object-based rig into the SOP context and take advantage of some of the tools offered by KineFX. Then, export animation back out to the object level for further use. To begin with, we'll have a look at some basic examples, and then move to an example using an object-level rig made with the built-in auto rigs. To begin, we'll start with some simple rig examples. This one is about as simple as you can get. Just basic FK. 3 bones. We can see that if we want to animate those, we're just using the rotate channels. Very simple. So to start our retarget, I'm going to create a geometry object. And inside that object, you can see that I've pre-made this network with some notes to myself. We're going to start with this node, the Scene Character Import node. And what this allows us to do is to point to a subnet. So in this case, we're pointing to the basic FK subnet, where we have our bones. And then we can decide, based on a pattern and on the type of thing that we want to import, what do we want to import from this subnet. And so in this case, I'm taking the bones, and that's it. I'm not really doing anything other than that. But you can see I have some timing options, and you can read the documentation on this node for more details about it. The output that I'm taking is the third output, and you can see that it's the animated pose. The middle output is the capture pose, and the first output is, if the little tooltip comes up, the rest geometry. In this example, I'm not using either of these, and in fact, in none of the examples I'll be showing will I be using captured geometry. We're just thinking about how to get the animated pose out. Apply retargeting to that, and then send that animated pose back out to the object level. So you'll see that I have Ghost Other Objects on. I'll turn that off. You'll see that when we bring them in, the 3 bones, they're all just stacked on top of each other here at the origin. So they're not showing their actual position. And if you want to see that, you can just throw a null here. And now we can see that we have 3 points in our scene. And because they are in a hierarchy at the object level, they'll show up parented to one another. And so we get this, what looks like just a polyline. Over on the left, I'm splitting this off and putting a time shift node that I've set to frame 1. This just ensures that there's no animated movement coming from this hierarchy. And then here in this attribute wrangle, I'm creating what's an attribute called an X-form target, the transform target. And I'm just setting that to the path back to that subnet plus the name. And so we can see that in the geometry spreadsheet. If we hide everything and just show name and transform target, you can see that the name of each of these joints is basic FK bone 1, 2, and 3, and then the transform target is that full path back to those bones. Then on the right-hand side here, I've just placed this rig pose so that we can use it as an example of how we can animate here at the SOP level and then send that back out to the object level. In a more complex example, this would involve retargeting or some other form of animation. But here I'm just using a rig pose to show that it does work. And lastly, in this scene, I have a scene character export. And this is the one that's going to do all the magic for us. It's going to take as its first input the rest pose of this hierarchy and an animated pose of that same hierarchy, and it's going to export it. Well, it's going to export it to the subnet, and again, this is the path to that basic FK subnet that I have at the object level. We have a list of parameters, and by default, that's translate, rotate, etc. But I know that I'm only really dealing with translation and rotation here, so I'm just going to remove these. I've turned off revert to defaults, and this is probably something that you're going to want to do almost all the time. And the reason is that in this very simple example, we're not doing anything weird with the pre-transforms. We're not making the position of these contingent upon any other nodes or constraints. And we don't have any odd values. All of these bones are, in fact, just sitting at their default values. And so if that was not the case, if we were doing something odd in here, that would flow through and get picked up by this revert to defaults. So when this node exports this animation, it would revert those nodes and those parameters to their defaults before writing the animation. And we don't necessarily want that. In fact, in my albeit limited experience with KineFX, since it's so new, I don't think you're going to want this on ever, just to be safe. And then I've turned off cache frames. You don't really need it. It doesn't really improve anything as simple as this. And I found that it was interfering with the other scene exports that I had going on here. And I was, in creating this tutorial, making lots of these over and over again. And so I didn't want anything to be cached. The rest of it, you don't really need to know much about. Again, you can look at the help to find out the details of all of these parameters. But for this simple example, what we have here is going to be just fine. So again, I'm bringing in the specific objects that make up my hierarchy. I'm freezing them in time so that I remove any kind of animation on this rest pose, making sure that they have a transform target. And then on the right-hand side, I've got some kind of animation. The scene character export also has a very cool parameter called live transform export. And in this case, I can turn this on, and what it will do is it will send this information live. So I can go into my basic FK hierarchy, and I can see that for each of these bones, I have a constraint override. And we can see that we're getting it from scene character export 1, and then there's an export obj transform inside transforms, and that's a chop network that is taking the animation and applying it as an override here to this bone. And what that means is that I can go back into our retarget, I can display this, I can ghost other objects so I can see my bones. And now, if I use my rig pose to apply animation here in KineFX, I get a live update of my object level bones, and they're doing exactly the same thing. So you can get live feedback on what's going on. And then once you're sure that the animation that you've applied here is what you want, and let's just do a very quick bit of animation. Frame 1, frame 24, that. Apply some keys. So now I have this bit of animation running live. Go back to the scene export. I'm going to turn off live transform export for now. I'm going to use an animation range. Oops. 24 frames. Now I can export that animation. It happens very fast because it's a very simple thing to export. And now if I go back up, I'll turn that off and look at my basic FK bones, you can see that each bone that's been animated has frames or keyframes. And here's the animation. You're going to get a keyframe on every frame, right? It's a baked animation. So you can go back and edit this to your heart's content. You can have a look at the keys themselves. So I can go and adjust these however I want. And since I'm not an animator, I'll leave this to an animator to do. The second example is very similar, except in this case, I'm using control objects as the drivers of our animation. And I think I have some baked animation on here already. Yeah, I do. And so the animation is being applied to the bones through a reference. So let's go up and see how that was done. So again, I have exactly the same network with the exception of this node. So I'm bringing in, I'll turn this off again. So in this case, I've brought in not bones, but the nulls that are being used for animation. I can go back and show that here. So it's these controls that are being animated, not the bones. And so I don't want the bones, I want the controls. So scene character import, I'm bringing in nulls, and I'm actually specifying them with this pattern. Then, because these are just three controls, they don't have any sense of hierarchy. I'm using the reparent joints node to create that hierarchy. So point 2 is a child of point 1, point 1 is a child of point 0. And then the rest is just as we had before. We have a rig pose here. We have our scene character export. And I can actually, should be able to use the delete animation button. And that should, I hope, yeah. So all of our animation's been deleted because this node is pointing to that subnetwork. And now I can turn on my scene character export, but in this particular case, the live transform export does not work. I can show you that it doesn't work by ghosting our bones and controls. Here I'm using the rig pose to animate using KinEffects. So you can see here that our KinEffects rig is animating. But even though I have live transform turned on, it's not being passed to these bones. And this is just a current limitation of the scene character export SOP. It's something that we're looking to address in a future update. But if we do a little bit of animation, let's just put that like that. Go down to 24. Goes back to default. Whoops. So here we have some animation. We can export the animation. And now, if we go back into our subnetwork, we can see that we have animation on. I think, yeah, I've turned that on, and so the chop override exists on the nodes, but it doesn't actually work right now. So I'm going to turn that off, just so we're not distracted by it. Go back into our indirect FK. You can see that there's animation on that control and on that control. And there we go. So a slightly different example than the straight FK. This is FK using controls, but the methodology is almost identical. For inverse kinematics, we're going to do something very similar. If I go into my basic IK, I have the same 3-bone rig. This time I'm using inverse kinematics, so I have a goal and I have a twist. Using a chop network with an inverse kin chop. So in my retarget, I have to do the same thing. Using the scene character import, I'm importing nulls, and in this case I'm just grabbing all of them. Here I'm attaching geometry to be used as control geometry, just by making a box, making it a little bit smaller. I'm giving it a name, in this case box, and then on the attach control geosop, I'm saying for all of the points, all of the joints coming into the first input, put a box on them. I can turn that off. There we go. And again, these are in a hierarchy. So our goal is a child of the root, and our twist is also a child of the root. And again, with the rig pose, I can animate. And let's turn ghosting back on. If I go back to my scene character export, I can turn on live transform export, use my rig pose, and you can see that the IK is working. And I can export that. Whoops, that's going to basic IK. We don't want that. Oh yeah, it is. Basic IK. There we go. If we go in, we can see that we have animation on our goal and on our twist. But again, you see we have animation, but we also have this constraint. And that constraint is coming from the live transform export. So I keep forgetting to do it, and that's kind of a good thing because it allows me to point out that this is something that you should remember. Before you export, turn that live transform export off. So you don't want to have that constraint there. You just want to have the animation itself. And then the last example is an indirect IK. So we have this hierarchy with an up vector controlling these bones. And each of these is a separate IK system. So a slightly more complex example, but one that we'll deal with in exactly the same way. We bring in our objects, in this case nulls. We attach control geometry to them, and we ensure that they are in a hierarchy. So this joint is a child of this one, is a child of this one, and this joint is a child of this one. We attach control geometry, we have our rig pose, scene character export, again pointing to the subnet from which we got them. Turn on live transform export. I can ghost these. Oops, there we go. And use the rig pose to animate each of these. So I can create animation here, or I can use animation imported from elsewhere. And then turn off Live Transform Export. Export the animation. Just takes a second. And there we go. We have animation on these controls. Any of them that I actually animated. So, simple examples. You'll certainly find much more complex things going on in production, but hopefully each of these provides a little bit of insight about how this works and the kinds of things that you're able to do. So just to go over some important aspects, the scene character import is very, very important for determining just what you want to bring in from the object level into SOPs. And the scene character export, you want to make sure that you're exporting to the correct subnet, exporting to the correct parameters, and then Live Transform Export is an excellent way of previewing what you're doing, but I do recommend turning it off before you export. And there we go. So next what we'll do is a much more complex example using a rig that was built using Houdini's auto-rig system. In this more complex example, we'll be using our character Eric, here rigged with the auto-rigs which come with Houdini. We'll also be using a piece of mocap supplied by our friend Luis, captured in his office. It's a good range of motion, testing all the joints, all the articulation points, fingers. Very useful. So to begin, we're not going to target this rig with our retargeted motion capture. In order to avoid cycles, exporting animation onto something that we're drawing from, what we're going to do is we're going to use a copy of Eric. And here I've just called him Eric1. And so this will be the rig that we send our animation to. And we'll be doing that inside this new piece of geometry. And on this piece of geometry, I've used the edit parameter interface to hide the transform, render, and miscellaneous parameters. And I've added two operator paths. One is the rig path input, one I've called rig path output. And I've done that just to simplify this interface and so that I can refer to these paths inside this network. I don't have to refer to anything out here. I have a very focused path here. To begin, we're going to be using our scene character import SOP. And I've done a couple of things here to make my life a little bit easier. The first thing that I did was, using the edit parameter interface, I created a string parameter that I'm calling autorigs nodes. And I'm using that parameter to hold all of the objects that I want to import from my rig. So you can see master control, head control, spine, arms, feet, etc. And then instead of using this pattern node to list each of these objects explicitly, I'm using a little expression, or rather a script, that will read each of these objects from this autorig nodes parameter that I've made, and then append the full path of the asset to that name. And so the result is that when I put in this parameter master control, what this script will resolve is object side effects Eric master control. This way I don't have to worry about editing this pattern parameter every time I want to add or remove an object. I can just do that editing here in this node, or rather this parameter. I find that it cuts down on the mistakes. The second thing I'm doing, as we did in our earlier examples, putting a time shift, set at frame 1, and you can see that the result of all of that is something perhaps a little bit confusing and a little bit messed up. We can get kind of an idea of what we're grabbing, but we don't really know what's going on here. And because I know that I'm going to need to reparent all of these things, I'm going to have to create a proper hierarchy out of all of these objects that I've grabbed from Eric. I just use the reparent joints node. I select all the joints and I set their parent to be none. And what that does, if I turn on points to be able to see them, is just create a flat scene full of joints. And this allows me a clean slate that I can use to reparent these properly in the next steps. So I've done that for the FK and for the IK. And the reason that I've had to do that is that the scene import node here, scene character import, will only bring in objects that are displayed in this subnet. And if I go back up to Eric, from which we are grabbing all of these objects, you can see that currently his arms and his legs are in FK mode. You can select one of these and can see that right now his leg is in FK. And so we are not seeing any of the IK controls. In order to see the IK controls, I have to put the leg into IK mode. Now the FK controls have disappeared, and the IK controls have appeared. Put that back into FK. And so what I've had to do with the scene character import is set Eric into FK and then go through the time shift, the reparent, in order to get the FK controls here. Then I've used a stash node to stash these objects. Then what I did is I went back to Eric and I set everything to IK, which turned off the FK controls, turned on the IK controls. Then I selected the scene character import, made sure to do a reload, and then fed it through the time shift, through the reparent, into this null, and now I can see these are the twist controls for the arms and the legs that were not present in our FK controls. You can see that they're absent. So that's something that you'll have to keep in mind with the scene character import. It will only grab things that are displayed, and anytime you make a change to those things, you'll need to reload. But because these things are super light, it's just a few points, I don't mind throwing them into a stash node to store them. Now that we have our FK controls, we need to set them up in a hierarchy. And I'm doing that with these rig Python SOPs, separating them out into spine, head, arms and hands, legs and feet, just for organizational purposes. You could use one node for this if you wanted to, but I find it nice to organize them in terms of sections. So with this reparent spine FK, from the KinEffects module, I'm importing the rig API, and then I'm defining a rig that I'm calling R. And that rig has a number of methods. One of them is parent. So I can say that the spine hips control parent should be the master control, and so on for each of these joints. Then I do the same for the head. You can see that now I have a hierarchy here. I do the same for the arms and the hands. You can see that along here. Just going through joint by joint and determining its hierarchy. And then for the legs and feet. And now I have a hierarchy in SOPs that represents our FK skeleton. Now that we've defined our FK hierarchy, we can import some animation. And I'm doing that with the FBX anim import. And here is the range of motion that we looked at earlier. And with this rig attribute VOP, I'm fixing a scale issue that's particular to this piece of motion capture. You may not have to do this at all. But if you go inside, you can see that I'm getting the point transform for every joint. Then I'm making sure that its scale is accurate. Then sending that back out to those joints. Again, this is not something that you may need to do, but I had to do it for this piece of animation. After that, we're into what you might be familiar as a kind of regular retargeting workflow. We're going to use the rig match pose to take that animation and fit it as best we can with our FK skeleton. And I've done a few tweaks in here. The thighs, the clavicle, upper arm, lower arm, just to match these up as best I can. Then I've put that through the map points node, map the points from the source animation skeleton to the target, which is our FK hierarchy. And then we can use the FK transfer, specifying translate and rotate using the mapping index that's generated by the map points SOP to transfer that animation onto our rig. And we can scrub through and see how that's going. It's pretty good. More work could be done, should be done on the hands here and in other little places. But for the purposes of this tutorial, this is just fine. You can see that everything's working pretty well. And then from here, we're going to take our FK hierarchy here, and the result of our FK transfer here, and we're going to feed that through these two switches. And these are here just so that I can show the FK transfer and the IK transfer using this switch. But what we're really looking at is just that. So in our scene character export, I'm doing the same things that I did in our simple examples, but in this case, I'm limiting the range from 1 to 200. I'm pointing my OBJ subnet to SideFX Eric 1 using translate and rotate. I've turned off revert to defaults, and I've turned off cache frames. And if we go up to the object level, we turn off Eric, who was our source rig. We turn on Eric 1, and that's our target rig. Then ghost other objects. You can see that we have Eric, and here's our FK transfer. And if I turn on live transform export, you'll see why this doesn't quite work. Sort of works. His hands move a little bit. He's jiggling around. So again, this is a simple limitation that we plan to address in the future. But we can export the animation. So I'll do that right now. So that took about 30 seconds. Not too bad for 200 frames. And you can see that the ghosted Eric 1 rig has moved his position. And we can scrub those first 200 frames and see how we did. Not too bad. Again, the mocap isn't the best. It's not been cleaned up and all the things that you would usually do to mocap, but successful. And this is something that an animator would go in and clean up and adjust to whatever you need to do. And if we go up to Eric 1, we can look at his parameters, and we can see all these parameters now have animation. Legs. It's all working well. So that's a demonstration of exporting FK from a rig through KineFX back onto an object rig. So I've deleted the animation that we put onto Eric 1. You can see that he's back in his default state without any animation. And now we'll try the same thing, only with an IK hierarchy. It's a little bit more complicated, but it's not too bad. So I'll take our scene character export and move it over to our IK output. We'll come back up to the top where we had our scene character import. And again, these are using the same nodes, but when I stashed these controls, let's turn that off for a moment. I did turn on the IK so that these things would be visible, then through these nodes into the stash. Then, as we did with our FK hierarchy, do the same thing with the IK hierarchy, which won't be the same. The FK controls and the IK controls could be very, very different. And so that's why we need to do these two processes separately. But using the same techniques, just defining the parent for every particular control. And the result is an IK rig represented in SOPs. And you can see it doesn't have knees, doesn't have elbows, because this arm is an IK arm. And the movement of this IK arm is defined by the movement of the goal and the root and the twist effector. And then the motion of those is solved by the IK solver, which rotates the joints. In order to transfer animation onto this IK hierarchy, we're going to do, well, it's a little bit of a trick. We're actually going to do the same scene character importing that we did with our FK and IK controls. But this time, we're just going to grab the bones. We're going to go through that same time shift, the same reparent joints node to remove all parenting, and stash it. And then we're going to reparent these bones. Then we're going to map using the map points SOP. We're going to map our IK controls to our imported bones using map points. You can see just mapping the controls to the bones. Then again, we're going to bring in that same animation, fix its scale, and now we're going to match pose to our bone rig. Not to our IK rig, but to our bones. After mapping the points, we can go into our full body IK. You can see that I've made some slight adjustments. I've bumped the iterations up to 50. That might be a little high, but I felt that it was necessary to get this to behave a little bit better. Again, we're using that mapping name attribute. And then down here in the configurations, I've specified that the spine bone 0, spine bone 7, and the head bone should have a greater priority. And what this does is it provides a kind of a hint to the solver to say, do what you need to do to get all of this to work correctly, but pay special attention to these bones, because these bones are important for the whole thing to work right. And it's important to remember that as valuable as this kind of technique is, if you put too many of these in, if you give too many hints to the full body IK, it actually gets worse, because the full body IK is trying to do what it knows to do, but now it's being told to do other things, and it can get quite hectic. So be conservative about how you use these constraints. We can scrub through and see that this is performing just fine, as well or maybe even better than our FK solution. You can see that we've got animation on our fingers. So pretty good. After we've done that, we're going to take our mapped IK controls and we're going to parent them to those bones using this VOP network. You can check out the details of what's going on here, but it's fairly simple. We're taking in the mapping attribute, and for every point, if the mapping isn't valid, then we're ignoring it, we're deactivating it. For the rest, we're getting the point transforms of the first input, the parent transforms of the first input, the point transforms of the third input, which is the retargeted animation, and the point transforms of the second input, which is our bones. You can think of these two as rest and animation, and we want to parent our IK using the rest to the animation. That's a way of thinking about this network. And then we're going to use a skeleton blend to blend the translate and rotates of our actual IK controls to that animation. You can see here are our twist effectors, and they seem to be behaving quite well. And as we did with the FK, we'll forget about those switches. So we have our IK controls, we have our animated IK controls, and now we can go into that same scene character export, again limited to 200 frames, pointed at Eric 1, translate and rotate, revert to default is turned off, cache frames is turned off, and in this case, unlike the FK, we can turn on live transform export. We can see that Eric is kind of doing something, but his hands look strange, and the reason for that is that I forgot at the beginning of this to turn him back into an IK rig. So I'll do that now quickly. So hands and feet, arms and legs. You can see now he's a little bit more better behaved. We can ghost Eric. And so now this is our IK rig with animation, and we are seeing the ghost of our object level Eric rig. And he's animating just fine. Again, with the FK, you'd want to spend more time with the match pose, and the same thing here with the IK. I didn't really spend a lot of time making it super great, but that's something that you'll want to do on your own. Thank you for watching this tutorial. As always, if you have any questions or comments, please contact us through our regular support channels or through the forums. Thank you very much.